Hi, today we are going to see how to solve the given linear programming problem by the method of simplex. Simplex method or simplex algorithm is an iterative procedure for solving a given LPP in a finite number of steps. So let us see the method of solving this by taking one example. Solve by simplex method. The given LPP is maximize Z is equal to x1 plus 2x2 subject to the constraints minus x1 plus 2x2 less than or equal to 8, x1 plus 2x2 less than or equal to 12, x1 minus x2 less than or equal to 3, where x1, x2 greater than or equal to 0. x1, x2 are positive. X1, x2 are called decision variables. Okay, it should be positive for any given LPP to proceed with. Okay, so now this form of LPP, we call it as general form. The first step in solving this LPP is we have to convert this general form to standard form. Okay, what is standard form of LPP? Take the subject to constraints inequalities and we are going to make these inequalities to equalities. How? By introducing slack or surplus variable. Here everything is less than or equal to, so we are going to introduce only the slack variable. Okay, so first step is to write the subject to constraint inequalities to equality form. So it becomes minus x1 plus 2x2 introducing slack variable S1, which makes this inequality to equality. Second inequality is x1 plus 2x2 less than or equal to 12. By introducing the slack variable S2, this becomes equal to 12. Third inequality is x1 minus x2 less than or equal to 3. So we introduce the slack variable S3 to make this equal to 3. So standard form means first making all the inequalities present in the subject to constraints to equality and then writing the objective function Z, maximize Z is equal to x1 plus 2x2 with the given decision variables. Along with that, the slack variables we have introduced. Here we have introduced S1, S2, S3. So for all the three introduced slack variables, the cost associated is 0. So plus 0 S1 plus 0 S2 plus 0 S3. So writing the given general form of LPP into the standard form is nothing but writing the objective function with the introduced slack variables with 0 cost and writing the inequalities present in the objective functions in equality form by introducing slack variable. So first step of writing standard form is done. Second step is we have to frame the simplex table. So what is simplex table? So general form of simplex table is this. That is Cj, here the column is XB, CB, and solution column, ratio column. So this is like skeleton form of your simplex table. This is how it looks. So now let us see what all these terminologies refers. So first column XP means it is basic variable. So here we have to write the basic variables and we start with the slack variables we introduce. So what are the slack variables we have introduced in this problem? S1, S2, S3. So we start with the introduced slack variables as the basic variables. CB denotes cost of that basic variable. So what are the costs associated with this basic variable? We have assigned cost as 0. So this is first iteration. So everything starts with the slack variables associated cost 0. Now what is CJ? CJ is nothing but cost of the objective function, given objective function. How will you write the cost? That is nothing but coefficient of the objective function. So it is nothing but 1, 2, 0, 0, 0. CB, costs associated we have written. Corresponding variables are nothing but x1, x2, s1, s2, s3. So here you have to write the corresponding variables. Okay, so now let us fill this matrix column space. How will you fill this? These terms are nothing but coefficients of the objective functions. What are the objective functions we have? First equation is minus x1 plus 2x2 plus s1 is equal to 8. Let us fill the coefficient. Coefficient of x1 is minus 1 in the first equation. Coefficient of x2 is 2. Coefficient of s1 is 1. There is no s2. There is no s3. Is equal to 8. Second equation is x1 plus 2x2 plus s2 is equal to 12. Coefficient of x1 is 1. Coefficient of x2 is 2. Coefficient, there is no s1, so 0. Coefficient of s2 is 1. There is no s3, which is equal to 12. Third one is nothing but third equation of subject to constraint. That is x1 minus x2 plus s3 is equal to 3. That is 1 minus 1. There is no S1, there is no S2, S3 coefficient is 1, which is equal to 3. Okay. After filling this, we have to find Zj, then Zj minus Cj. What is the procedure to find Zj? Zj is nothing but the Cb into this coefficient. That is 0 into minus 1 plus 0 into 1 plus 0 into 1. Here it is 0. Similarly, to fill this entry, it is 0 into 2 plus 0 into 2 plus 0 into minus 1. So, it is 0. So, here third entry, 0 into 1 plus 0 into 0 plus 0 into 0. That is 0. Fourth, because here everything is 0, you will automatically get the values as 0. Zj minus Cj. Next, you have to find Zj minus Cj. So that is this entry minus the entry on the top. Zj minus Cj. Okay. So 0 minus 1 is minus 1. 0 minus 2 is minus 2. 0 minus 0. 0 minus 0. 0 minus 0. Okay. So actually the simplex method, we can just see it in two phases. The first phase is nothing but identifying the pivotal element. Next phase is making that pivotal entry 1 by doing row operation. So now we are doing the first phase of identifying the pivotal element. So that for that we are doing all these operations. So for that first you have to find Zj and then Zj minus Cj. Remember Zj is nothing but the entry in Cb with this coefficient and add the value. Cb 0 into minus 1 plus 0 into 1 plus 0 into 1 corresponding entry. Zj minus Cj is Zj, the value we have got, minus the value of Cj, the cost on the top. Okay. So next step is with this value, we have to find the most negative of Zj minus Cj. Now we have found the values of Zj minus Cj. What is the most negative of this? Most negative value is nothing but minus 2. Okay. So most negative and circle the corresponding column, which we name it as leading column. Next, we have to find the leading row. So, how will you find leading row? First, for that, we have to find the ratio. Ratio between what? Solution and the entry in the leading column. So, here 8 by 2, 12 by 2, 3 by minus 1. So, here you remember while we find the ratio, the denominator should be positive and other than 0. If you get this denominator as negative, for that corresponding ratio, you won't find. Okay. Suppose, while you do the problem, if all the entries of that leading column to be negative, then in that case, you cannot find any of the ratios. Then we conclude the problem saying there is no optimal solution. Got it? So this ratio you have to find only for the positive values present in this leading column. Solution divided by the value in the leading column. So here 8 by 2, 12 by 2 and there is no ratio for the third because it is negative. Okay, 8 by 2 is 4 and 12 by 2 is 6. Now you go for the least value. Okay, so least positive value is 4 here. So circle the corresponding row and we name it as leading. Okay, the entry common to both leading row and leading column is, we name it as pivotal element. So here the entry pivotal element is 2, which is common to both leading row and column. So here the pivotal entry is 2. Okay, we have identified the pivotal entry. So means what? Corresponding basic variable is S1, corresponding decision variable is X2. Means S1 leaves the basic entry and X2 in the place of S1, X2 enters. So in the basic variable column, S1 leaves and corresponding decision variable X2 enters. Okay, so we move to this second iteration of making this pivotal entry 1 and the remaining entries in that corresponding leading column to be 0. So phase 2, our aim is to make the pivotal entry 1 and the remaining entries in that leading column to be 0. Okay, we just name it as row 1, row 2, row 3. So to achieve this, we are going to perform the row operations. So newly formed row, we name it as row 1 dash, row 2 dash and row 3 dash. Okay, so now S1 leaves and X2 enters. So in the place of S1, I put X2, S2, S3 as such. So cost of X2 is 2, which I write from the top cost. Okay, 2, S2, S3 cost remains 0. So now I have to make this pivotal entry 1 means I have 2 there. When will this become 1? When I divide this by 2. So divide the row throughout by 2. So R1 dash is nothing but R1 divided by 2. So minus 1 by 2, 2 by 2, 1 by 2, 0 by 2, 0 by 2, 8 by 2. Okay. So next one, I have to make the remaining entries to be of this column to be 0. Take the row 2. The column is 2 here. The value is 2 here. I have to make this value 0. When this 2 will become 0, to make this 0, I have to perform the row operation between this row 2 and this newly formed row 1. Okay, here I have 2, here I have 1. When will this 2 become 0? When I multiply this 1 with 2 and subtract both. So the row operation which I have identified is new R2 dash is nothing but R2 minus 2R1 dash. Got it? So I have to multiply this R1 dash, this row with 2 and subtract both. Okay, to make this remaining entry 0, I should perform the row operation only with the newly formed row R1 dash. Okay, so now 1, so let us do this row operation with the remaining entries. So 1 minus 2 into R1 dash. The entry here is minus 1 by 2. So which is minus of minus plus. So 1 plus 1 which is 2. So the entry here is 2. 0. And here 0 minus 2 into 1 by 2. Which is minus 1. Third entry is 1. Minus 0 into whatever we do, it is 1. 0 minus 0, 0. 12 minus 2 into 4, which is equal to 4. So the entry here is 4. Next, my aim is to make this minus 1 to be 0. Performing row operation with newly formed row, that is R1 dash. So here, minus 1 is there, here 1 is there. When will this minus 1 will become 0? When you add both, simply add both. So the row operation identified as row 3 dash is nothing but row 3 plus row 1 dash. Simply adding both. So row 3 plus row 1 dash. So row 3 entry is 1, first entry minus row 1 plus row 1 dash is minus 1 by 2. So 1 minus 1 by 2. So which I will get it as 1 by 0. And the third entry 0. Here I have 1 by 2. So 0 plus 1 by 2 is 1 by 2. 0 plus 0, 0. 1 plus 0 is 1. 3 plus 4 is 7. Simply adding this row 3 entries with this row 1 dash entry. Okay. So I have got all these newly formed rows, making pivotal entry 1, remaining entry 0. So my task of phase 2 is done. So next I have to do the same operation of finding Zj minus Cj, most negative, least positive, identifying pivotal. I have to repeat this loop till I get all the values in Zj minus Cj to be 0 or positive. Okay, so I proceed the iteration. Find Zj. So how will you find Zj? Is nothing but Zj is nothing but 2 into minus 1 by 2 plus 0 into 2 plus 0 into 1 by 2. So 2 into minus 1 by 2 is minus 1. 2 into 1 plus 0 into 0 plus 0 into 0. That is 2. 2 into 1 by 2 plus 0 into minus 1 plus 0 into 1 by 2. That is 1. 2 into 0 plus 0 into 1 plus 0 into 0, 0. 2 into 0 plus 0 into 0 plus 0 into 1 is 0. Next is Zj minus Cj. Cj is nothing but the value on the top, which we will use for the throughout the simplex table. So Cj is nothing but the value on the top, this value. So the Zj value we have found now, we have to subtract Cj value, which is on the top. Okay. So Cj values are 1, 2, 0, 0, 0. So I have to subtract this Zj value with the Cj value got. So minus 1, minus 1. So minus 2. 2 minus 2, which is 0. 1 minus 0, that is 1. 0 minus 0, 0, 0 minus 0, 0. So this is my Zj minus Cj. Next, find the most negative value. Most negative, only negative here is minus 2. Corresponding column, we name it as leading column. To find the leading row, you have to find the ratio between solution and the leading column entry. First, we cannot find because here the entry is negative. Next, you have to find 4 by 2, 7 by 1 by 2, which is nothing but reciprocal 7 into 2. So 4 by 2 is 2, 7 into 2 is 14. So here least positive is 2, circle the corresponding row. The common value is my pivotal entry. So here the pivotal entry is 2. Okay, moving to phase 2, that is I have to make this pivotal entry 1 and the remaining entries present in this column to be 0. Before that, the corresponding basic variable of pivotal is S2. So S2 leaves this basic variable column and which one enters? X1. Corresponding decision variable X1 enters this column. So S2, this iteration S2 leaves and X1 enters. And my pivotal entry is 2. Okay. So I move to the next phase of making this pivotal entry to be 1 and the remaining entries to be 0. So next phase, X2 as such. Cost of X2 is 2. S2 leaves. In the place of X2, X1 enters and S3 as such. Cost of X1 is 1. Cost of S3 is 0 as such. Next, newly formed row, I name it as R1 double dash, R2 double dash, R3 double dash. Now my task is to make this entry 1. That is, to make 2 1, I have to divide by 2. So the row operation I identified is I have to divide R2 dash throughout by 2. So dividing R2 dash by 2, 2 by 2 is 1, 0 by 2 is 0, minus 1 by 2, 1 by 2, 0 by 2, 4 by 2. Next task is to make minus 1 by 2, that is R1 dash entry to be 0. When will this minus 1 by dash will become 0? We have to do the row operation only with newly formed row, that is R2 double dash. There minus 1 by 2, here I have 1. When this minus 1 by 2 will become 0, when I multiply this by minus 1 by 2 and add both. So the operation I identified is R2 double dash is R2 dash plus 1 by 2 into R2 double dash. Okay. So I have to multiply this row R2 double dash by 1 by 2 and add it with the R1 dash. So first entry automatically becomes 0. Second entry is nothing but, what is the second entry there? 1. So row operation identified as 1 minus 0 into 1 by 2. So which will become 1. So the entry here is 1. Next one is 1 by 2 plus 1 by 2 into R2 double dash entry is minus 1 by 2. That is 1 by 2 minus 1 by 4. Taking 4 as LCM, 2 minus 1 by 4. So 1 by 4. The entry here is 1 by 4. There I have 0 plus 1 by 2 into 1 by 2. That is 1 by 4. Here entry is 1 by 4. 0, 0, 0. So 4, next entry is 4 plus 1 by 2 into 2. That is 4 plus 2, that is 5. Okay, so the entry here is 5. Next, I have to make this entry 1 by 2 to be 0. For that row operation, what I should perform? Here 1 by 2, here I have 1. Okay, when this 1 by 2 will become 0. So when I multiply this 1 with 1 by 2 and when I subtract both. So R3 double dash is nothing but R3 dash minus 1 by 2 R2 double dash. Okay. Remember the remaining entries of that leading column, I should make 0 only by performing row operation with newly formed pivotal row. Okay. So here this entry will become 0. So what is the row operation? We have identified R3 dash minus 1 by 2 R2 double dash. Okay. So here 0, 0. So it becomes 0. Here 1 by 2. So how this changes? 1 by 2 minus 1 by 2 into the entry here is minus 1 by 2. So which becomes 1 by 2 plus 1 by 4. That is taking 4 as LCM. 3 by 4. Okay, the entry here is 0. Here it is 1 by 2. So the row operation is 0 minus 1 by 2 into 1 by 2. That is minus 1 by 4. There it is 1, here it is 0. So 1 minus 1 by 2, 0 is 1. So 7, last solution column is 7. Here you have 2. So the operation is 7 minus 1 by 2 into 2. That is 7 minus 1, that is 6. So here solution entry is 6. So this is how I have made this pivotal entry 1, all the remaining entries in that column to be 0 by performing row operation with newly formed pivotal row. Next, I have to find Zj and then Zj minus Cj. So first let us find Zj. Okay. Zj is nothing but, one second, Zj. What is Zj? 2 into 0 plus 1 into 1 plus 0 into 0. That is 1. 2 into 1 plus 1 into 0 plus 0 into 0. That is 2. 2 into 1 by 4 plus 1 into minus 1 by 2. So the operation is 2 by 4 minus 1 by 2. Taking 4 as LCM, 2 minus 2 by 4. That is 0. Next 2 into 1 by 4 plus 1 into 1 by 2. So 2 by 4 plus 1 by 2, which is nothing but taking 4 as LCM. 4 by 4, that is 1. Last one is 2 into 0 plus 1 into 0 plus 0 into 1, that is 0. Zj minus Cj. We have to subtract this Zj value with the Cj on the top. Okay, already we have seen now what are the entries in Cj. 1, 2, 0, 0, 0. Subtract with that entry. 1 minus 1 is 0. 2 minus 2 is 0. 0 minus 0 is 0. 1 minus 0 is 1 and 0 minus 0 is 0. Here there is no negative term at all. Zj minus all Zj minus Cj is greater than or equal to 0. We have reached this position. Means what? Optimum solution is obtained. Okay, when optimum solution is obtained, that is when you see all Zj minus Cj to be positive, in that case, we need not find the ratio. So instead, we'll be finding this solution entry value. That is 2 into 5, same procedure. 2 into 5 plus 1 into 2 plus 0 into 6. 2 into 5 is 10 plus 1 into 2 is 2. That is 12. So this is the solution column. We shall conclude this by combining, consolidating all the values. So, solution is we have got Z as 12. And what are the values of the decision variables? X1, X2. So, this X1, X2 values, we should take only the solution values. Okay, so X1 is equal to 2, X2 is equal to 5, and max Z is equal to 12. So we have obtained the optimum solution as 12 with the decision variable values as 2 and 5. Okay. So this is what simplex method is concerned. So here there are two cases where you will conclude there is no optimum solution. One case is, situation is where when finding when you find the ratio column, all the entries present in this leading column will be negative. In that case, we will conclude that there is no optimum solution. Second one is you will get all Zj minus Cj 0, but there will be some slack variable present in this with non-zero value. Here also slack variable present in the basic variable column, but the value of slack variable is 0. But when you see all Zj minus Cj 0, but slack variable present in the basic variable column with non-zero value, in that case also you will conclude that the solution is non-optimum. We cannot find the optimum solution. Okay, so here we have got all Zj minus Cj to be greater than or equal to 0, and the slack variable which we have introduced is in 0 level. So optimum solution is there and we have concluded it as 12. I hope you are all clear with the simplex method. Thank you.